So in this video, I'm going to take you through Gaussian elimination with partial pivoting. So welcome to my channel, which is Calculus Family. If this is the first time you're visiting this channel, kindly subscribe and please turn on the notification button so you get updated when I post interesting videos like this. So Gaussian elimination with partial pivoting is an upgrade on the naive Gaussian elimination. Okay, so in our previous lessons we solved naive Gaussian elimination. Please visit the video so you get the concept as we progress. So Gaussian elimination with partial pivoting deals with the inadequacies of the naive method. So what are the inadequacies? So we have one to be division by zero. Division by zero. So we realize that whenever we are finding the multiplier, we try to divide the element you want to make zero over the entry of the pivot row, right? So there is a possibility of getting division by zero, and we can eliminate that using the Gaussian elimination with partial pivoting. And also we have what we call the round off errors. So they are all being corrected using the partial pivoting. So let's see how we do that. Now when we talk about the partial pivoting, it means that we are going to manipulate our coefficient matrix so that we can avoid the division by zero and the runoff errors, which are always due to the strict nature of naive. So now let's first write our system of equation into the augmented matrix. So I'll have 5, 1, 2, then 34. Okay, then I'll have 0 because the x component here is vanished. I'll have 4 minus 3, then what's 12, right? Then I'll have 10, negative 2, 1, neg 4. Once you have this, you know that Gaussian elimination, the naive one, would always make sure that this and this turn 0, right? But there is one thing you should take note of. In partial pivoting, the goal is to make sure that the entry with the highest entry, when you take the magnitude of each entry, okay, the entry with the highest magnitude should always be at the top. Should always be at the top rows, okay. So meaning we have to switch row 3 here to row 1, then also the row 2 will come down. So let's see something here. So I'm going to have 10, neg 2, 1, negative 4. Okay, so I'm switching. So I'll say that row 1, you bring this sign here, row 3. Okay, then I'll have my 0, 4, negative 3, 12. Then this becomes 5, 1, then 2, 34. Okay, so what this means is we are trying to bring up this which has the highest magnitude up, okay, and that is the concept behind partial pivoting. So at this point, since this second term here is already 0, we can move ahead converting this here to 0. Okay, so how do I convert the last row, the first entry in the last row, to 0? So I'll do that using a row operation as well as a multiplier. So I need a multiplier. How do I manipulate 10 so that it will become the same as 5? It's simply by what? This over that. Is that not it? So as I said, multiplier is always equal to the entry you want to make 0 over the entry of the pivot row. Okay, so 5 over 10 multiplying the row 1, and that gives us what? Half row 1. So my row operation simply becomes my row 3 minus what? Half row 1. Is that not it? And all this should enter my row 3. After the operation, my resultant should be here. Okay, yeah, should be there. So I'm going to have this 10, neg 2, 1. I'll have negative 4, right? 0, 4, neg 3, 12. But the last row is where the operation is affected. 5 minus half of 10, which is 5, 0. 1 minus half of negative 1, it will be 1 minus minus 1, giving me 2. Then 2 minus half of 1. So that is 2 minus half, 1.5. So 3 out of 2. Okay. Then 34 minus half of negative 4. So it will be 34 minus 2, giving me what? 34 minus 2, giving me 36 here. So we are done with our first step. So the second step, I said once you convert the last two entries of the first column to 0, you move to the 2 by 2 matrix here. Okay. So within this, we are going to find a new multiplier in a new row operation. So it's still row 2, row 3. This is our focus. So at this point here, how do I make these two here 0? How do I send these to 0? So I need to manipulate 4 so that the 4 will be the same as the 2, so that when I subtract it will be 0. And how do I manipulate? So my multiplier is simply equal to the 2 that I want to turn 0 over what? 4, multiplying the pivot row, which is row 2. Okay, and this is giving me half row 2. And now my row operation now becomes my row 3 minus half row 2, all going into row 3. So simply I'll have 10 like 2 1 like 4, 0 4 like 3 12, right? Then 0, so 2 minus half 4 becomes what? 0. Okay, 3 over 2 minus half negative 3 over 2. So 3 over 2 minus 3 out of 2, right? This becomes 6 on 2, giving me 3. 36 minus half of 12, which is 6, giving me 30, right? So this is the end of the forward elimination. So you can see that this partial pivot is the same as the naive, just that we always become cautious of the fact that any entry which has a high magnitude and is a leading entry should move up. Okay, so here we saw that 4 was higher than 2, 10 was higher than, you get it. So it's the same thing. So now at this point, we only have to find our unknowns using the backward substitution. So finding x, I said using the backward substitution, we start finding the values of what? Z, we move to y, then move to x. Okay, so I'll have 3z equals 30. Obviously, z is equal to 10. I'm going to have 4y minus 3z is equal to 12, right? And z is 10. So we'll have 4y minus 30 equals 12. I'll have 4y is equal to 30 plus 12, 42, okay? So divided by 4, my y is what? 42 divided by 4, which is 13. So y is 13. Then you move to the z, okay? So to move to the z, we are going to have the first equation, which is 10x minus 2y plus, this becomes what? Z is equal to negative 4. So here I'll have 10x minus 2 multiplying the y, which is 13, plus the z, which is 10, equals 4, negative 4. 10x minus 26 plus 10 equals negative 4. This gives me minus 16 plus minus 4, 10x, right? So this will go 20. So 10x is equal to 20. X is then equal to 2. Okay. So now s is equal to 2. X is equal to 2. So I'm having s equal to 2, y is equal to 13, and z is equal to 10. Right. Z is equal to 10. So this is the end of our partial pivoting method of solving system of equations, which falls under Gaussian elimination. Thank you for being with me in this video. Hope seeing you in the subsequent videos.